Hi, I'm Ariana Stickel. I'm a postdoctoral scholar in the Department of Neurosciences at UC San Diego, and I work in the study of Latinos, investigation of neurocognitive aging, or the Sol Inca lab. And I want to thank the conference organizers for inviting me to speak to you today about common risk factors for dementia that are identified among predominantly white samples and studied among non-Latino white samples. And today we're just going to discuss how these risk factors might apply to the Latino population in the US. And before we jump into things, I just want to mention that I'll be using the terms Hispanics and Latinos throughout this talk. These are the generally preferred terms by our participants, but I understand and I want to acknowledge that these aren't necessarily the preferred terms for everybody. Some people might prefer the term Latinx. A lot of Latinos just prefer to go based on their country of heritage. So like I'm Mexican or Cuban or that sort of thing. But I think it just speaks to the heterogeneity within this population. All right, and that being said, the other thing I want to mention is I'll primarily be focusing on work that I've done with my collaborators, not necessarily doing an exhaustive review of the Latino cognitive aging literature. But just to give you some reason why we should care about Latino cognitive aging in general, in the last decade, Latinos made up over half of the population growth in the US. And we also see the same pattern or a similar pattern among older adults, 65 and older, where Latinos are one of the largest growing demographics within the older adult age group. And when you combine that with data that suggests that Latinos are actually at increased risk for Alzheimer's disease compared to non-Latino whites, it's no wonder why Latinos are expected to have the largest number of increased cases of Alzheimer's disease and related dementias or ADRDs compared to any other group. And so this is very alarming, and yet we still don't know a whole lot about cognitive aging and risk factors for ADRDs in this group. And this is very troubling, not only because it's a disservice to the Latino community, but also because it does pose a public health risk. And I'm going to be talking about several factors today related to cognitive aging, cognitive decline, dementia risk. Now, I'm mostly going to be focusing on risk factors, and the specific factors I'll be focusing on are underlined here. And I tend to think about both risk and protective factors in terms of whether they're modifiable or more fixed or non-modifiable, just because I want to think of what are some ways that I can intervene and what are some things that maybe I can't change, but I should be looking out for as a potential risk factor if I'm a clinician treating somebody. And here we have, again, these are both risk and protective factors that I have here. For example, being socially active might be something that protects against cognitive decline and aging, whereas certain risk factors like hearing impairment might actually increase risk for cognitive decline and dementia. Now, I also want to say here that some of these factors that we traditionally think of as fixed aren't quite as static as we once thought they were. Even genetics are becoming less and less static. But in general, I would say hearing impairment, I actually tend to think of it as something that's more modifiable, because if you wear hearing aids, you're able to overcome that. And then, gender is very fluid, and we're accepting that it's more and more fluid, although I would say among our older adult sample, it's still pretty static. But I want to acknowledge that. Now, I want to go over the data sets that I'll be discussing here. One of them is the Hispanic Community Health Study of Latinos, or the HCHS SOL. And this is a large study of over 16,000 Latinos. This is a prospective-based cohort study, representative of 4 different regions in the US that you can see there. And these are all Latinos, and those that were 45 years and older actually were invited at baseline at HCHS Sol to complete cognitive testing as well. And over 9,000 individuals did complete that cognitive testing. Of those individuals, we asked them to come back for an ancillary study, the Sol Inca, in which they would complete a second time point of cognitive testing. And over 6,000 Latinos did complete that second time point of testing as well. So we're very fortunate to have those data. And that second time point of testing was around 7 years later on average. Now, we also have an ancillary study called the Sol Inca MRI, which uses magnetic resonance imaging to look at the brains of some of these individuals. We're aiming to collect neuroimaging on approximately 2,800 people, and about 2,300 of those would be individuals from the Sol Inca who have 2 time points of testing. About 300 of those would be individuals who are younger who wouldn't have any cognitive testing, but would allow us to look at brain aging in a more lifespan-based approach. And those data are currently being collected. So we have approximately 1,400 scans at the moment. And again, our goal is to get up to 2,800, and we're on our way to reaching that goal. Now, we're also preparing to collect a third wave of cognitive data. And this has been delayed due to the pandemic, but we're hoping to get back to that very soon. And we're especially excited for these data because we'll be able to start determining if somebody has progressed on to dementia at this point. Now, the other data set that I'll be referring to throughout this talk is a combined NAC and ADNI data set. These are 2 convenience-based samples that, quite frankly, they don't have a lot of Latinos in their samples. This is why I decided to combine them. This is some of my earlier work. And the Latinos that were included here, they were Latinos who identified their race as white. And so these are ones that I selected because they identified their race as white. And we did that initially because we wanted to only look at differences based on ethnicity and not have an additional potential confound based on race. Unfortunately, there weren't enough Latinos who also identified their race as Black, Asian, or Native American to be able to do to have the power to do a more stratified analysis or interactive analysis looking at race and ethnicity all together. So this is a huge limitation. This is much less generalizable, much more limited. Even though I would say the majority of Latinos, when they're asked to report their race, they do tend to report white more often, but it's not a vast majority. It's just a slight majority. And what Latinos perceive as themselves as in terms of their race really varies. Some Latinos just really feel like they're being forced to pick a race because they just identify as Latino and nothing more beyond that. And so, because race is so socially constructed, it's a little bit difficult to interpret these data, especially for a group like Latinos who are really focused more on ethnicity than race for the most part. Now, that being said, the way that we selected our participants, so we had our Latino group, and then we did pseudo random sampling, and it was stratified so that we were able to match non-Latino white participants to our Latino group, and we matched them on age, education, which is very difficult to match on, as well as gender, mild cognitive impairment, or actually cognitive status. So we only included people who were either cognitively healthy or mildly cognitively impaired at the testing date that we selected. And they were also matched on apolipoprotein E4 status. Now, again, these are the risk factors that I'll be talking about today. And I'll be talking about some of them in more detail than others. You'll notice that gender is there in parentheses, and that's because I'll just be talking about it in the context of these other risk factors. We're actually exploring this a little bit in more detail right now, so we don't have too much data on that. Now let's start off by talking about some of these less modifiable risk factors. So number one, aging. Across the board, aging is the number one risk factor for Alzheimer's disease and related dementias. This is pretty consistent across races and ethnicities. You can see this anytime you look at most normative data when you're looking at things like processing speed, memory, executive functioning. You tend to see that with increasing age, scores tend to be lower. And this is true for Latinos as well. And we actually have some data from the Sol Inca that suggests that those individuals who were in our study who were 70 to 86 years of age, they were about over 1.5 times more likely to have mild cognitive impairment than those who were 50 to 59 years old. This isn't shocking or earth-shattering data, but it's something to note. Now, what's really lacking in the Latino cognitive aging literature is what is going on in the aging brain of this population. And so these are the data that I want to dig into here. So these are from the Sol Inca MRI study, so our large, diverse set of data on Latinos. These are about 1,400 Latinos here. And again, not so surprising, we looked at several different measures of brain structure. So we looked at brain volumes, we looked at cortical thickness, and we looked at more global measures, so total gray matter volumes, total white matter volumes, but also some specific regions, for example, hippocampal volumes. And across the board, older age was associated with poor outcomes. So smaller gray matter and white matter volumes, larger ventricle size, greater white matter hyperintensity volumes, which is a measure of cerebrovascular health, small vessel disease. And I think what was more interesting were these data where we separated men and women. And that's what we'll be looking at here in these plots. So at the bottom of each of these plots, you'll see age on the x-axis. And then on the y-axis, you'll see this is a cortical gray matter across the whole brain on the left-hand side. And then on the right-hand side, you'll see cortical gray matter specifically for the frontal lobes. And what I'd like for you to notice here is that for our younger individuals, we don't see a huge difference between our men and our women. The men are here in gray and the women are in this mustard golden yellow color. But when we look at older age ranges, especially going into mid to late 50s into the 60s and beyond, you start to see the two groups diverging a little bit more, such that men seem to have a steeper aging slope, so brain aging slope. It seems like brain aging might be exacerbated among men. Now, these aren't longitudinal data, so we don't have those types of data yet anyways. But this is telling us that, maybe there's some differences between men and women in terms of how their brains are aging. And if this is the case, it would be really helpful to look at why this might be. Now, what you'll see here in these plots is on the left-hand side, over here now we have hippocampal volumes on our y-axis. And we actually see kind of not quite the reverse pattern, but a slightly different pattern where men are actually, and women, they actually start off a little bit significantly differently, where men tend to have larger hippocampal volumes than women. But then in older ages, you see this difference minimize and basically disappear. Again, men look like they might be experiencing a steeper brain aging. But again, these aren't longitudinal data, so we can't completely say that for sure. Now, in some of the other data that we have for some of the other measures, so for example, white matter hyperintensities here on the right-hand plot, the y-axis, you actually see that regardless of gender, we saw the same basic slope of brain aging, where increased age was associated with greater white matter hyperintensity volume, which indicates greater small vessel disease. So for this measure of cerebrovascular health, we actually didn't see differences, which is quite interesting. So overall, I would say those data suggest that one, clearly aging is a risk factor for brain aging. And although I didn't show any data, there's pretty consistent evidence in the literature that yes, aging does impact cognitive functions among Latinos. And then we saw some interesting data, at least at the level of the brain, that suggests that there are gender differences here too. Not necessarily pointing quite to one gender being more or less susceptible, although in this case right now it might be that men might be more susceptible to brain aging, but it's not completely clear. And we need to dig into that a little bit more, and we are doing that in some of our current work. Now let's move on to apolipoprotein E4 allele status. So the ApoE allele itself, you can have 3 different variants of this allele, or any combination of 3 variants. So there's E3s, E2s, E3s, and E4s. And you have 2 of these. And if you are at least among whites, if you are an E4 carrier and just have 1 copy of that allele, so an E4 heterozygote, you are at approximately 3 times increased risk for developing Alzheimer's disease specifically. Now, if you have 2 copies of the E4 allele, so you would be an E4 homozygote, then you actually have a 12 times increased risk of Alzheimer's disease. And, these are approximate, and this is based on non-Latino white samples. Now, when it comes to Latinos, the literature is on E4 status and cognitive aging is much more mixed. First, E4 status is not, the E4 allele isn't as common among Latinos as it is among non-Latino whites. So that creates some differences there just based on prevalence. But even among Latinos that have the E4 allele, this relationship to increased risk for Alzheimer's disease isn't as consistent across studies. And so one thing, again, that was missing in some of these data, we're looking at what might be going on at the level of the brain. So using that combined NAC and ADNI data set, so this is a smaller data set, and again, these Latinos are very specifically identifying their race as white. We decided to compare these 2 ethnic groups on how ApoE status might be related to brain volumes. And so, interestingly, we didn't find any interactions between E4 status and ethnicity on brain volumes here. Rather, we saw that across non-Latino whites and Latinos, E4 carriers had smaller total white matter volumes. And we also saw that there were specific regions of the brain where E4 carriers differed from non-carriers across both ethnicities. And to do that analysis, we performed a voxel-based morphometry analysis, which lets us look at across the whole brain and identify specific regions, not necessarily, and they're not pre-specified and they're not restricted anatomically or anything like that. And what you'll see here in this figure is that the regions where we saw differences between E4 carriers and non-carriers were in bilateral temporal regions. And in this figure, left is left and right is right. This is not in radiological view. And this region on the left here, which you can see here also in the sagittal image, you'll notice that it's in the temporal area, but it also seems to start to extend into potential parietal areas. And so it could very well be following a nice clean white matter track there. Unfortunately, we don't have enough diffusion imaging on our Latinos in this cohort to actually test that out in a good way, in a sufficient way. But again, we're seeing that E4 status among this group of Latinos who identify their race as white does seem to be impacting brain volumes. And in these regions that are particularly sensitive to changes in Alzheimer's disease, the temporal lobes. Now, we decided to take this one step further by looking within the Latino group of the SNAC and ADNI combined cohort. And we did this because when we were initially starting these studies, we wanted to know if acculturation might be protective against some of these traditional cognitive aging risk factors. So in general health literature, among Latinos, less acculturation or hanging on to Latino culture and not adopting as much of the Anglo-American culture is actually associated with better health outcomes, especially cardiovascular risk outcomes. And so we wanted to see if the same protection that's conferred on some of these health outcomes is also conferred onto brain aging and cognition. So to test this in the context of ApoE in the brain, what we did was we split our Latino group into carriers and non-carriers, but also based on their language preference. And unfortunately, the NAC and ADNI datasets don't have a good measure of acculturation. So really, this is like the most basic proxy measure of acculturation. It's by no means a good one, but it at least lets us start to dig into this a little bit. So presumably, those that prefer Spanish as their primary language would be less acculturated, and we would hypothesize more protected against chronic illness and potentially, in this case, E4 related changes to the brain. Whereas those that preferred English might be more acculturated and less protected. And so I want to point out that these sample sizes are so small, so take this with a grain of salt. But when we look at this split, and we're looking at whole brain white matter volumes here, what we found was that the only group that differed from the other groups were our English preferred speakers who were E4 carriers, and they had lower whole brain white matter volumes compared to each of the other groups to different extents, but they actually significantly differed from their Spanish-speaking E4 carrier counterparts. And no other group differences were observed. It was only between the English-speaking carriers. And so this actually does seem to give at least a little bit of support to this idea that there might be differences based on acculturation. It might just be differences based on, language use, or it could be something completely different. But at minimum, it shows us that there's some heterogeneity in terms of how ApoE status might be impacting the brains of Latinos. Now, I was lucky enough to join the Sol Inca team when an investigator, Inat Granat Hershkovitz, was starting to look at E4 status in this large Latino aging cohort. So we had data on over 4,000 Latinos, and these are diverse Latinos. And what she found was, well, first what she did was she broke people down by ancestry. And so this is genetic ancestry. So everybody's genetic ancestry is a little bit different. You can trace it back to different continental origins. And for example, somebody might have their genetic ancestry as, let's say, 60% Amerindian, 30% African, and 10% European. So everybody has different proportions of these different ancestry groups. Now, so what we have here plotted on the bottom is the proportion ancestry, and you can see each of these different groups in their different respective colors. And then on the y-axis, we have the odds of significant cognitive decline among E4 carriers compared to E3 heterozygotes. And what we found was that for those of African and European ancestry here in the red and the blue, there wasn't really any significant declines in between E4 carriers and E3 carriers. There wasn't a differential decline, based on proportion of ancestry. And you can see that here by those non-significant p-values. But for those with very high Amerindian ancestry, we did see this interesting finding where there were differences in cognitive decline over a 7-year period between E4 carriers and E3 heterozygotes. And this was in the opposite direction of what we expected. So here, E4 carriers actually were less likely to show significant decline than those E3 carriers. And this is completely opposite to what the standard literature in predominantly white samples suggests. And luckily, this has actually been replicated in other Latino cohorts. So this isn't just a one-off finding. This does seem to be consistent across some Latino cohorts. And I think this really just gives us the best evidence to show why we can't assume that one risk factor for Alzheimer's disease and related dementias in a specific group always applies to another group. We just cannot assume that. And really, there are very nuanced relationships. And so I would say that, we've seen evidence that maybe for Latinos who identify their race as white, maybe they have more European ancestry. Maybe there's a little bit of risk there. But as you saw with those data on genetic ancestry, those individuals with Amerindian and with high proportions of Amerindian ancestry, E4 status was actually a protective factor against cognitive decline. So, it's a very nuanced relationship here, and something that, we can dig into more moving forward. All right, so now let's discuss some more traditionally modifiable factors. I'll start with cardiovascular disease risk. So cardiovascular disease risk factors, things like diabetes, hypertension, obesity, hyperlipidemia. These are risk factors, and some stronger than others, for Alzheimer's disease and related dementias, especially vascular dementia and Alzheimer's disease. And particularly when onset in midlife. There's some data to suggest from Claudia Kawas's group that cardiovascular disease onset in older adulthood, late life, may actually be protective against Alzheimer's disease. But for the most part, most individuals, especially our Latinos, are actually in having these cardiovascular disease risk factors in midlife. So those those findings, it's probably not going to be a protective factor for them. Now, these are some data from the combined NAC and ADNI sample. And here, what was done was we just looked at cognitive performance on different cognitive measures in different cognitive domains. And we split individuals by whether or not they had a cardiovascular risk factor. Specifically here on the left, we're looking at hypertension, and on the right, we're looking at obesity as measured by body mass index. And overall, what we found was that our Latino group, when they tended to be more susceptible to lower cognitive scores or worse cognitive performance in the context of cardiovascular disease risk. So let me explain that a little bit more. So here in this left plot, here we have our scores for a measure of task switching or set shifting. This is Trails B divided by Trails A from the Trails making test. So higher scores actually indicate worse performance here. And what you'll notice is that our Latinos who are hypertensive, as designated by the gray bar, they actually had significantly higher performance, which again, worse performance compared to their normotensive Latino counterparts and even compared to hypertensive non-Latino whites. And no other groups differed. It was just this Latino hypertensive group that had significantly worse performance compared to these other groups. Now, when we look at the scatter plot on the right, what you'll notice here is that we have body mass index on our x-axis, and higher scores indicate obesity. So 25 and up indicates overweight, 30 and up indicates obesity. So here on the y-axis, we have digits span backwards, raw scores. So this is a measure of working memory, and here higher scores indicate better performance. So what I want to point out is that our non-Latino whites in this dashed line, they're also represented by these gray diamonds. The relationships between body mass index and working memory aren't that strong. You can see by the R square here, less than 3% of the variance is accounted for. And so very negligible, non-significant correlation. But among our Latino group, with higher BMI scores, we saw poor working memory performance. And body mass index accounted for over 11% of the variance in working memory scores among the Latino group. So that was significant. And it was significantly different from our non-Latino whites. And what was interesting is not that only that Latinos seem to be more susceptible to these poor cognitive outcomes in the context of cardiovascular disease risk, but these findings were specific in this case to executive functioning. These are two measures of executive functions, but we also looked at measures of learning and memory and processing speed. And for those tests, there wasn't a differential negative impact of cardiovascular disease risk by ethnicity. So then we took it a step further and we decided to look at what was going on with the brain at the level of the brain. Again, we performed a voxel-based morphometry study here. And for this, we were looking at how body mass index, blood pressure, both systolic and diastolic, were associated with gray matter volumes and how that might be modified by ethnicity. What we found was that ethnicity did not modify any relationships between diastolic blood pressure and brain volumes, nor between body mass index and brain volumes. But when we looked at systolic blood pressure, we did see some differences by ethnicity, and you can see them in these plots here. So on the x-axis for both of these plots, we have systolic blood pressure. Higher scores indicate worse blood pressure, higher blood pressure values. And on the y-axis, we have gray matter volumes. On the left-hand plot, we have gray matter volumes in the left medial temporal lobe, and in the right-hand plot, we have gray matter volumes in the left precuneus. And you'll notice here that for our non-Latino whites, there's this slope that's somewhat positive, but it's not significant. And they're in the blue here. But our Latinos, we see a more striking and negative slope, such that higher blood pressure was associated with smaller brain volumes in these two regions, as you can see by the red line. And I don't have it on here, but the percent variance in these gray matter volumes that was accounted for by blood pressure was around 25% for Latinos. That is massive. That is very significant. And what's even more striking is that these regions of the brain are regions that are sensitive to early changes in Alzheimer's disease. So again, even more concerning that this might be indicative of increased risk for Alzheimer's disease. We don't know for certain, but it is troubling. And again, it's suggesting that Latinos might be at increased risk compared to non-Latino whites for changes, for brain-related changes. Now, I've been talking about individual risk factors, but now I want to start talking about combined. I've been talking about individual cardiovascular disease risk factors, but I want to talk about multiple cardiovascular disease risk factors now, because quite frankly, many people, especially within the Latino community, have comorbid cardiovascular disease risk factors. And so for this particular study that I'll be showing you some data from, we were looking at how obesity alone is related to cognitive functioning and cognitive change over a 7-year period. And this is in our diverse Sol-Inca sample. And how it's related to cognitive declines as well over that 7-year period. And so we also wanted to control for other cardiometabolic abnormalities. These are things such as high blood glucose, high blood pressure, hyperlipidemia, those sorts of things. So if an individual had 2 or more of those cardiometabolic abnormalities, they were considered cardiometabolically abnormal. And what these data suggest, and I'll point out here, I want to point out the last 2 columns of each of these plots. So what these data suggest, first of all, is that obesity alone was not significantly associated with cognitive function or changing cognitive function when we took into account these other cardiometabolic factors. Now, when you looked at the combination of obesity plus cardiometabolic status, we started to see some really interesting findings. So on each of these plots, you'll have on the x-axis the metabolic abnormality status and obesity status. So these first 2 rows show individuals who are, or groups that are non-obese but differ in metabolic abnormality, cardiometabolic abnormality. And again, the ones I want to really highlight here are our 2 obese groups. This 3rd column from the left here is our metabolically normal obese group. And then the last column is our metabolically abnormal obese group. And you can see there's a huge difference here between these 2 groups, so that when you have both risk factors, you're really taking a hit. And really across the board, we saw that again, cardiometabolic abnormality was really the main player here. But when you add obesity to it, you just see this striking difference. And we saw that for our global composite measure of cognition, but also our individual tests. So we saw that for learning, memory, you can see it for word fluency, processing speed, another processing speed measure here, and then to a lesser extent, set shifting and task switching. And I also want to point out that we saw that not only for cognitive performance, but we also saw that for cognitive declines over that 7-year period. All right, so now let's go into a more continuous measure of cardiovascular disease risk. So here we're looking at the Global Vascular Risk Scale, or GVRS. This is a scale similar to the Framingham risk scale, but it's supposed to be more appropriate for diverse samples. And so what we saw across all of our participants was that higher GVRS scores were associated with 1.75 times higher odds of mild cognitive impairment. But when you split up the group by gender and looked at men and women separately, we really saw this striking difference, such that for our men, higher GVRS scores were not as strikingly associated with increased risk for MCI as they were for our women here in Black. You can see this very steep rise among our women here in Black here, where higher GVRS scores really increase mild cognitive impairment risk. And I think this is so interesting when we think about gender and in the context of some of those MRI findings that I showed you earlier, where it looked like men were having this exacerbated brain aging, except for white matter hyperintensities. There we saw very similar patterns among men as in women. And so there might be something about cardiovascular disease risk that really puts women on the same playing field as men in terms of brain structural damage or cerebrovascular damage. But here, what's scarier is that actual cognitive outcomes are very different, with women's showing in really exacerbated pattern. And so, again, I just want to point out that we want to look at we need to look at so many different intersections of risk, demographics, and aging in this Latino population to really get a better grasp on cognitive trajectories and dementia trajectories for this population. And so with that, I would say that we had sufficient evidence here, and even in the literature, there's sufficient evidence to suggest that cardiovascular disease risk factors are risk factors for cognitive declines, poor cognitive outcomes, increased risk for MCI. When looking at those data comparing non-Latino whites to Latinos, Latinos might even be at higher risk for poor cognitive outcomes in the context of cardiovascular disease than non-Latino whites. And I know we don't have any data here to look at dementia prevalence or incidence, but there are data, for example, by Mary Hahn's group in the SALSA study that do suggest that cardiovascular disease risk factors like diabetes and more significant cerebrovascular disease like stroke are very much associated with increased risk for dementia. All right, so now we're going to discuss the last the last risk factor here today, and that's hearing impairment. Now, hearing impairment has only recently really been getting attention in the dementia risk literature. I think it's gotten little bits of attention before, but now it seems like it's really really coming into the limelight. And last year, there was a Lancet article suggesting that hearing impairment was actually the modifiable risk factor that, if eliminated, would lower dementia prevalence the most. So just to explain that a little further, if we completely eliminated hearing loss, this article projected that dementia prevalence would decrease by 8%. And that was the largest reduction of any single modifiable risk factor. It was larger than if we eliminated smoking, if we eliminated diabetes, all sorts of modifiable risk factors. Hearing impairment was the one that would make the biggest difference if eliminated. So that's great if we can prevent hearing impairment. But another thing that was reviewed in this article, to a lesser extent, there's not a lot of studies on these, was that yes, hearing impairment increases risk for dementia, but if you wear hearing aids, you actually mitigate that increased risk. You're actually not quite at that same level of increased risk. So there's a potential intervention here. Now, there's not a lot of studies. I haven't seen randomized controlled trials. There might be something out there that I haven't seen, but I haven't seen any looking at hearing aid use and how that corresponds to dementia risk. But there's something potentially there. Now, the question is, among Latinos, is hearing impairment even an important risk factor for cognitive changes? And then, if so, are hearing aids a viable intervention? Well, I won't be able to answer that second question, but let's address the first question. So I want to give credit where credit is due. There was a study using the HCHS SOL, the very diverse Latino sample, that did show that hearing impairment was associated with poor cognitive outcomes among this large Latino group. Now, what we did was we kind of followed this up, looking at hearing impairment while taking into account cardiovascular health. And the reason we did this was, one, as I've shown you, cardiovascular health seems to have major impacts on cognitive health for Latinos. But also, some people speculate that cardiovascular health might actually be the driving factor, might be related to both increased hearing impairment, increased risk for hearing impairment, and increased risk for cognitive decline. And so it might actually be driving that relationship between hearing impairment and cognitive impairment. So in this study, we decided to see just how robust these hearing impairment findings were when we started to take into account cardiovascular health. And what we found overwhelmingly was that hearing impairment was still an important factor in terms of cognitive outcomes. And these are just cross-sectional outcomes. We haven't looked at changing cognition just yet. We're planning to do that soon. Now, just to go over these data here, these we actually had audiometry studies. So these are pretty much gold standard measures of hearing impairment here. So on the x-axis, you'll have no or yes, whether there was hearing impairment. And then on the y-axis, for each of these plots, you'll have the specific test that was administered. And on all of these tests, higher scores are better, reflect better performance. So overall, what we found was for learning, memory, word fluency, and then our global cognitive composite, hearing impairment was associated with poor scores on these tasks. The only test that we didn't see any differences for was our processing speed task here, the digit symbol substitution test. But overwhelmingly, hearing impairment was associated with poor performance. Now, when we started to look at the intersection between hearing impairment, and cardiovascular health, we saw something very interesting come up. So we used a latent profile analysis to classify cardiovascular health, and we derived 4 groups from this. So there was our healthy group who had very good outcomes, much better than the average. We had our typical or average cardiovascular health outcome group. We have this group who we called hyperglycemia. So these individuals had very high blood glucose levels, but otherwise average cardiovascular health. And then we have our high cardiovascular risk group. So these individuals had poor cardiovascular markers across a wide range of indicators. And so what we found was that if you had high cardiovascular risk, it didn't really matter at that point whether you had hearing impairment or not. Your scores were relatively low already. But for this group, this hyperglycemia group who had high blood sugar, but otherwise average cardiovascular health, when you added hearing impairment to the mix, we saw significantly lower scores, specifically on learning and memory. And we thought this was really interesting because these learning and memory tasks are verbally presented tasks in which somebody has to learn a list of words. And so there might be several factors coming into play here. One hypothesis might be that individuals who have hearing impairment have to have more cognitive load to just hear and attend to learning this list of words than with somebody with normal hearing. And so that might make it more difficult for them to really learn and take in those words. Now, another possibility is that hyperglycemia, or really high blood glucose, and hearing impairment are kind of doing a double hit or 2 hits to the brain. Now, we don't actually know what's going on at the level of the brain yet. Again, this is a future study that we'll be pursuing hopefully soon, but these are just a couple of our hypotheses. There are many others, but really overall, this suggests that both of these risk factors have important independent contributions, but also they have an interactive effect with each other: cardiovascular disease risk and hearing impairment. And what is also really important, I think, to note is that in a larger study using the HCHS data on all the individuals 18 years and older, so regardless of age range, when individuals who had hearing impairment were asked if they used hearing aids, 95% of them were not using hearing aids. Only 5% of the individuals who could use hearing aids because they had hearing impairment did not use them. And there may be many reasons for this. There's a significant chunk of our sample who are uninsured. And even with insurance, hearing aids can be very hard to obtain. And there just might not be physicians who are even thinking about hearing loss in this group. There might be physicians who have diagnosed hearing loss but might not be promoting or suggesting hearing aid use. We don't know, but we need to do I think this really begs us to look into how can we use public health means to promote hearing aid use in this population where it's so underused, and potentially, based on some of these data, could have big impacts on cognitive health. It seems like it's a really good opportunity that should be capitalized on. All right, so I would say that we have some evidence to suggest that hearing impairment is a risk factor for poor cognitive outcomes. We still need to see if that actually translates to differences in cognitive impairment and Alzheimer's disease later on down the road, but I think we can at least say that it's associated with poor cognitive outcomes. And so just to sum everything up, overall, we found that several of those risk factors that we looked at, you can go back to that checklist. We see a lot of checks on here. A lot of those risk factors that have been identified in non-Latino whites do seem to apply to Latinos, but there were some big differences that I think should really be highlighted. First, the apolipoprotein E4 allele, we saw very nuanced links to cognition based on continental ancestry or genetic ancestry. And we also saw differences when we were looking at that very specific sample of Latinos who identified their race as white, where it did seem to be a risk factor, but maybe only for those who preferred English as their primary language. Again, that was a much smaller sample. And that, again, that seemed to show risk. But when we looked at that genetic ancestry, and among those with very high proportions of Amerindian ancestry, we saw that the opposite. E4 status was protective against cognitive declines, which again has been replicated in other studies. So I think this again really highlights that we can't assume that every risk factor identified among whites applies to non-white groups. And then secondly, I want to point out the cardiovascular disease risk factor piece of this, where we saw in some of those, again, in some of those comparison studies using the NAC and ADNI data set, that Latinos actually might be even more susceptible to than non-Latino whites to poor cognitive performance in the context of cardiovascular disease risk. And in some of the data that just focused on Latinos in the Big Sol Inca data set, we saw that cardiovascular disease risk and how it impacts cognitive outcomes, that might differ by gender. And so we really want to explore that more. And then I've heard people say, well, in cognition, it's important, but does it really matter for this group, even beyond, even if we don't even think about dementia risk, does it really matter for this group? There are so many other things going on. Well, we have a study, a 2020 study in the Journal of Alzheimer's Disease that suggests that, yeah, it probably does matter. I'm very biased coming from a neuropsychology background. Yes, cognition always matters. But this study showed that cognitive performance at baseline at HCHSOL predicted impairments in activities of daily living, so everyday functioning, among our diverse Latino sample on average 7 years later. So from baseline cognitive performance, it predicted daily functioning on average 7 years later. That's big. And it predicted in the way that you would expect, where worse cognitive functioning was related to poor everyday functioning. So that means, people are less likely to be able to work. People might need to rely on family members more and all sorts of things. And so this is crucial and this is critical. And again, we would really be doing the Latino community and our public health system a disservice if we ignore cognitive aging among Latinos. And I just want to point out some of the limitations. We didn't do any in-depth investigations of sociocultural variables. I didn't mention this in some of the studies, but in several of our Sol Inca studies, we do control for some sociocultural variables like socioeconomic status, sometimes acculturation, other things. But there's, I've already shown you some nuanced interactions with these risk factors. Now, we still need to explore other interactions or modifications by acculturation, by migration. And these are studies that we're currently working on. I actually have an ADRC pilot grant that is looking at acculturation and cognitive outcomes, and acculturation in cardiovascular health and cognitive outcomes in the Sol Inca data set. And if you're interested in those data, come check out my symposium talk at the Alzheimer's Association International Conference. But we also have other studies looking at migration. And again, we're hoping to add in these multiple layers of not just looking at cognitive data, but also incorporating brain data. We're just now getting fluid-based biomarker data, which is really exciting. These are actually plasma-based biomarkers. So we'll be able to incorporate biomarkers, sociocultural variables, and actual objective cognitive testing to really hopefully get a more holistic picture of cognitive aging in this very diverse community. And with that, those are some of our future directions. I kind of already said that. But with that, I'd like to thank my mentors and colleagues. I want to especially point out Drs. Gonzalez, Taraf, DeCarli, and Gallo, who are all affiliated with the HCHS Sol and Sol Inca. I'd like to thank others in the Sol Inca laboratory, especially Kevin Gonzalez. He did a lot of the analyses for some of these papers. And then for the NAC and ADNI studies, which is actually from my graduate work at the University of Arizona, I want to thank my committee members and especially my graduate advisor, Dr. Lee Ryan, for that. And then finally, I want to thank AD Rickmar, who again is funding some of my pilot studies. And I want to thank our other NIA support and NIH support here. And with that, I will end it. Thank you for your attention.